All right, now I want to take some time and go through some of the specific things that we see in entomology writing that we don't necessarily see in other types of English writing or in other types of even scientific writing. This is something that you're going to learn as you start reading more and more scientific papers, as you go on in your careers, all that sort of stuff. Every discipline has its own little shorthand. Every discipline has its own way of doing things. And it's sort of a pain in the butt to try to figure it out on your own, simply because you're going to be turning in papers for publication. You're going to get dinged, or you're going to have reviewers tell you, hey, you need to write it this way. And you're like, okay, well, why wasn't that in the author guidelines? And why didn't you tell me what's going on? So what I've tried to do is collect all those little things that we constantly have to remind authors about, that we constantly have to teach people, but haven't been, listed in a writing book or something. This way you actually have it so that you know what's going on. So let's start with the scientific names. So you'll be dealing with a lot of scientific names when you write in entomology. I mean, we're talking about all manner of different species of flies or fleas or whatever else you're going into. So first things first, and this is something hopefully you know by now, especially if you've been in one of my entomology classes. When you write out a scientific name, you need to italicize it. So the genus is capitalized, and the species is lowercase, and they're both italicized. This is a way to communicate that we're talking about a genus and a species in particular. So if you haven't been in one of my previous entomology classes, I go into this a little bit, but here's a quick reminder if you have. Most of these names are based on the Latin or the Greek or something of that nature. They're based on these root words. So you will see these same types of names in a bunch of different groups. So there are other Massellaria genera or species out there that aren't flies. So this particular one is a fly, but there are other things that have the species Massellaria. So you can't just come out and say Massellaria and expect that everybody knows you're talking about the fly versus some other species. Okay, so you always need to put the genus with it, and you need to italicize it to communicate that this is a genus and a species. Okay, so do not leave it unitalicized, because what this is saying is this is now either a family or an order or a phylum or something else. These non-italicized words indicate something other than a genus and a species. And since we're talking about the genus and the species, we want this. Now, you always have to write both the genus and the species. Never just put Massellaria. Now, you can say it when you're talking to somebody and you both know what you're talking about. You can say just Massellaria, like verbally, I could say to you, well, we're talking about Massellaria right now because we all know we're on the same page. When we write it, though, you always have to put the genus and the species. However, you only have to write out the genus the very first time you write the organism, because then you can kind of assume, especially in a paper, that you've written it, you've introduced everybody to what you're talking about. Now you don't have to waste your time writing both. So the second time you write the genus and species, you can abbreviate the genus. Usually the abbreviation is the first letter of that genus name. And remember, it's capitalized just to indicate it is in fact a genus, then a period, and then the spelled out Massellaria. We never abbreviate the species if we're writing out the species name. We can abbreviate it as SP if we don't know the species, or if we're only talking about a certain genus. Let's say I'm talking about all the flies in Cochleomya, then I could say Cochleomya species, blah, 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 blah. Right, but see Massellaria there. Now, you will find as you go through the genus and the species, and I think I have this a little bit later too, that sometimes the first letter of the genus is the same as another genus. So in this case, there are two fly genera. One is Cochleomya, one is Chrysomya. They both start with C. So in order to differentiate between those two, you can put two letters at the beginning. So in this case, it would be CO period Massellaria. Or if I chose it to be Chrysomya, it would be CH period. Which one you decide to put 2 letters and which one you decide to put 1 is up to you. There's no standard for that. I usually go with the genus that I put first. Let's say I'm listing 2 genera, Cochleomya, Chrysomya, and I put Cochleomya first, and the first one that I wrote gets the C, while the second one gets the 2 letters, the CH. I mean, that's just the way that I do it. There's no standard, though. But that allows me to differentiate between the 2 genera as well to make it as clear as possible. Always remember, the whole point of scientific writing is to be as clear and as precise as physically possible. So if something is confusing to you as you're writing it, it is hell going to be confusing to your readers. The only exception to this abbreviation, you never abbreviate a genus when you're starting a sentence with that genus. So if you're beginning a sentence with Cochleomya macellaria, even after you have introduced this genus and species, you always spell out the genus. So do not put a C period. Don't abbreviate at the beginning of a sentence. This is just one of the things that we kind of just know in entomology, that you will get dinged on by editors and stuff like that. So when you see this in your reviewed papers, I want you to really focus in on this sort of thing. You always spell out the genus at the beginning of a sentence, and you always spell it out the first time. Now, finally, there's no need to put a definite article in front of a scientific name. So think of a scientific name like a person's name. So you wouldn't say, today I had lunch with the Adrian Brundage. Well, you might if I'm famous, but you wouldn't. You'd say, I had lunch today with Adrian, or with Adrian Brundage, or Dr. Brundage, right? So you don't need to put the Cochleomya macellaria because it's a full name. So instead you say Cochleomya macellaria or C. macellaria, and you're good to go. Now, the first time you write out a scientific name of any insect, this is one of these weird foibles that you're going to find in pretty much just entomology. I haven't seen this very much in other disciplines like wildlife or bacteriology or microbiology or whatever else. But the first time that you write out the scientific name of any insect, you need to do 3 things to make it very, very clear what you're talking about. So remember, just a second ago, I said that there's a lot of different shared names, right? You'll see Rufifosses or Chrysomya or these root words in other species. So first, you need to write out the name completely. So again, here's Chrysomya rufifossis, like I said. So you want to make it very clear. Here's the genus, here's the species. Okay, so you write it out like this. Second, you need to find the scientist that first described the species. So in this case, you may have to just go find another paper that has already done this for you, or go to the official species list somewhere. Usually it's easiest in other papers. Just go find another paper that talks about this species in an entomology journal, and they will have done this work already. But you're going to find the author. We do this sort of to pay homage to the author, or pay homage to the person who actually discovered and described this species. Because that's a big pain in the butt to do. If you've ever done any taxonomy, imagine finding a new species, trying to ID this thing through all these keys. You can't figure it out. You don't know what it is. Then you have to go find more of these specimens and describe it and publish it. And it takes years. So in order to, give a little bit of due to the person who did all that work, we put their author name next to it. Okay, so find out that scientist who described the species and put the last name of that scientist in parentheses after the very first mention of the species in the body of the paragraph, or in the body of your paper, or in the title. So even if you're putting the species in the title for the first time, you need to put the author. So in that case, it'll look like this. Okay, so in this case, it's Macart that first identified Chrysomya rufifossis, and so we're just saying this is the person who did it. This also is super helpful in case you want to write about a species, or you're reading a paper about a species and you've never heard that species name before. So those of you who have been in entomology a lot, you know that we spend a lot of time changing the names of these species, right? So if you are reading a paper and you've never heard this name before, but it should be a species that you know, you can go and see who the author is, go find their original paper describing the species, and then see if we've actually changed the name, and that's why you don't recognize this name. So you put this this scientist name, ooh, that was hard, right after that first mention of the species, even if it's in the title. First time, put the author's name. Then, this is the one of the more important things, one of the more useful things I think that we do in entomology, is because there are so many species and because we don't memorize all of them at all, you want to put after that initial author name and after the first mention of the species, in another set of parentheses, you're going to put the order and the family of that species. There. This is super helpful because you will likely go on in entomology and become an expert in one or two groups. So like me, I'm an expert in flies, or at least I'm trying to be, and the other species out there I don't know nearly as well, especially when we're talking about homopterans or hemipterans or beetles. Man, I don't know. But you will see that these same names, Chrysomya rufosses, they come out in other species or in other families, other groups out there. So if I'm talking about the fly Chrysomya rufosses or CH rufosses, I need to make it very clear that this is the fly. So in this case, I put the species name, genus and species spelled out, the author, and then I'm making it very clear this is Diptera in the family Calliphoridae. You're going to find as you read these papers, this makes it so easy to understand what the author is talking about. Because I don't necessarily recognize the species name. I can scan and see, oh, we're talking about Calliphorid flies. Great. Because when you start doing research or literature search in these species, you're going to look up names. You're going to do say a species search on Google Scholar, and you're going to find that there's a whole bunch of different groups that come up. So you can very quickly scan, even in the title, and see, okay, Chrysomya rufosses, oh no, they're talking about that. The rufosses, that's a beetle. Because in that case, it'll say Coleoptera colon something else. I don't know what family that would be in. But the Coleoptera colon Scarabidae. That's the biggest one. Okay, so that way I know, okay, that's not a paper I'm looking for. I'm looking for the Diptera Calliphoridae. So this is what the very first instance of the species name should look like. Even if it's in the title, you want it like this. Now, when I write, if I put it in the title or the abstract, I will also put it for the first time in the intro, just to make it very, very clear. Some journals you'll find don't necessarily require it to be a second time in the intro. I just want to make it as clear as possible because sometimes you just sort of scan the title and then you don't reread the title when you are reading the intro. So I just try to make it as clear as possible. It's up to you if you want to do that, but you have to do this the first time. So this is what it should look like the first time you write out the genus and species name. All right. Now on to something other than the genus and species name. This is writing numbers in scientific writing. So a general rule for writing out numbers, if the number is under 10, you're going to spell it out in words. So 0 through 9, you're going to spell it out in words. All those single digits, spell it out. If it is over 10, or the second it gets to double digits and higher, then you can use numerals. So in this case, if I was saying there were 8 species collected or 8 specimens collected, I would spell out the word 8. If it was 18, I'd use numerals 1-8 to spell it out or to write it. Okay, so if it's under 10, you are going to spell it out in words all the time. So in this case, this is what it looks like. There were 3 species represented in the sample. So I spelled out 3. There are 146 species. I spelled out I put 146 in numerals. 11 is in numerals again. So that's just the way it is. Under 10, you spell it out. The other thing you want to know is that when you start a sentence with a number, you always spell it out. Always. So if you are starting, if I said, say 146 species were collected, I would spell this out in words rather than numbers because it's starting the sentence. Never start a sentence with numerals. Always spell them out. Make sense? Okay. Now on to the materials and methods. And this is something I'll be harping on as well when we get to the materials and methods lesson. But when we are writing out materials and methods, again, we're trying to be as clear as possible. And in materials and methods, we are trying to make it so that Anybody who wants to replicate our project can get the exact same materials that we get, or at least a close approximation. So what we have to do in this case is add manufacturers to the materials. The reason we do this is because different companies will have slightly different formulations for things, even things that are very simple like hydrogen peroxide or whatever else. Okay, so they will have slightly different, maybe proprietary formulations, and you want people to be able to exactly replicate your results using the exact right chemicals and the exact right things. What can happen otherwise, though, is if you don't put the manufacturer, you just say, okay, I use this like a some sort of wipe or something, like a disinfecting wipe. They can go get a different one. They'll do the same test, but they might end up with different results. And then they're going to say, well, you obviously did the test wrong because I did it and it was different. So let me give you a quick example. So there is a disinfecting wipe that is sold by Costco. It's just their generic Costco brand disinfecting wipe. They say on there like equates to, some of the name brand ones, Lysol and Clorox and whatever else, like they do with these generic brands, right? So I was working with a group out of University of Florida, and they were doing some blood spatter testing, and they were using just these disinfecting wipes to clean up the blood spatter after they were testing for it. When you do blood spatter testing, you use a substance called luminol that reacts with the hemoglobin in the blood and causes a glow. Okay, now what's neat about luminol is even after you clean it up with bleach, you can still see the blood, like the trace amounts of hemoglobin. So we were, they were working on this thing, whatever, they had this luminol. They were using several different types of wipes. When they were using normal Clorox wipes, it was you could still see some traces of blood behind and some luminol still glowing through. When they used the Costco version, though, it completely deactivated the luminol. Completely. It stopped it from glowing. So they noticed this as they were cleaning things up, and they did a quick little test and went, this is the only wipe that completely deactivates this chemical. So now imagine if I wrote a paper about this and said we used a disinfecting wipe and it deactivated luminol, but I didn't say which one or the manufacturer. So somebody tries to replicate this and they don't have access to Costco brand wipes. They wouldn't be able to recreate my paper, and they would call BS on me. They say, no, it doesn't. You just did it wrong. No, I didn't. I was just using a wipe that I did not communicate. And of course, we try to call Costco and they won't tell us what's in it because it's a proprietary mix. Uh-oh. So now you know how to clean up blood. FYI, just go get the Costco wipes. But anyhow, that's a quick aside. But that's why we try to be as specific like this, because if something goes wonky, we don't want to put ourselves out there and say, hey, I'm a bad scientist. Haha. No, you're not. You just used something different, and when somebody replicated it, they used a different chemical or a different makeup or a different something, which is why the results are different. So this all goes back to being as precise and specific as possible so we can make sure that we're not, dragged on the carpet, dragged our name through the mud because somebody else could replicate our work. So for materials and methods, this is extremely important. You want to put down whatever you used, either hydrogen peroxide or the centrifuge, the equipment you used, or whatever else, and you're going to put in the manufacturer right after. So in this case, you're going to look up who made that chemical. Usually it is a large corporation, Sigma, Aldrich, Johnson & Johnson, really common. They own pretty much everything, it feels like now, who made that equipment, whatever it was. And you're going to put that company in parentheses right after that product is. So it's the main company that makes whatever product you're using. Then you're going to put the city and the state where the headquarters of that company is, where it's housed, shall we say. So in this case, it's Sigma Aldrich in St. Louis, Missouri. The reason we put the city and the state is because with these worldwide conglomerates, with these really large corporations, they often have country-specific headquarters that make products for that particular country. And each country has its own laws, each country has its own requirements for products, all those sorts of things. So you might have a slightly different formulation of even something as basic as hydrogen peroxide in St. Louis or in the US than you do in Tokyo or in Canada or in South America. So it really, really depends. And then this way, if somebody's trying to replicate this in Europe or in Russia or somewhere, and they're using the same company, but they get different results, you can then look into and say, okay, well, you used this particular chemical from your country. Let's look into how it's different, and maybe that can explain why we're getting different results. Make sense? So this is what it looks like the first time you mention this stuff. You put the chemical or the whatever, the object that you're using, you put open parentheses, the name of the company that made it, put a comma, then put the city and the state, or the city, state, country, whatever, that where this thing is housed. So this is what it looks like for things in the US, the city and the state. Because we are writing in the United States, we don't have to put the country necessarily. If we're using something where it's from a different country, so in this case, these scanning electron microscopes from this company Akashima in Tokyo, Japan, then we put in the city and the country there, simply because we're very self-centered here and this is how it works. Okay, makes sense? That way, somebody can then find these same things. Now, sometimes you're going to find something very simple like cotton balls. You're not quite sure exactly where those things were found. So if you have an object, or you're editing a paper that uses cotton swabs or something very basic like this, go ahead and look up the most common manufacturer of those things, like Johnson & Johnson. 90% of the cotton balls you buy are from this particular company. Okay, put that one in there and just assume it's right. There you go. And it's pretty straightforward. Make sense? Okay, now, you're simply trying to make it possible for other people worldwide to get the same product that you did. So this is super helpful if somebody's trying to replicate this in another country. Maybe they can't get Johnson & Johnson, but they can get something else. It gives them a way to find something that's a local equivalent of what you had. Now, when you're writing these things out, you may find that you have written out, say, a website or a catalog number. You don't need any of that information. So you don't need the website. There's no need to mention the website, the catalog number, the product number, nothing like that. Think about those things. Would the product number be super useful? Not really, because people in other countries may not have access to that exact product number, and it's just extra words. It would just be more confusing. So this is all you need. The company, the city, the state, the company, the city, the country, if it's in another country. All right. Now, sometimes you may need to mention a place where these things were found. So in this case, this is especially common when you are writing or reading about collections of insects. So you'll see a lot of these types of papers out there where people went out and collected insects or trapped for insects or something like that. So you want to be moderately specific for these things, but not overly so. So again, think about a worldwide audience and what information would they need to know in order to get the idea of what you did. So in this case, let's say I was out collecting flies, as I normally do, and I found some on the side of 2818. That's, right here in the middle of town in College Station. I found some roadkill on the side of 2818. If I publish a paper and I say it was found on FM 2818, is anybody going to know what the hell I'm talking about? Have you tried talking to somebody from California or New York or Canada or Russia and say 2818? Do they know what you're talking about? No. This is a highway that is specific to our town, and we know about it because we live here. But if you ask them about the highways in their towns, you have no idea what those are. So the specificity you're looking for is you want to say that this was found on the roadside, right? But you want to say then the city and the state. So that's all we're looking for, is the general area, city and state. because again, this is going to help people understand in general where it is without being so specific that people are like, I don't know what the hell you're talking about right now. So if you see somebody say, the corner of this road and this road, no, that's not necessary. What you need to say is roadside, College Station, Texas. That gives everybody enough information, because things like collections, you're not only going to find them on the side of that particular road. Insects can move. They're not that specific. But you do want to know sort of the general area. You want to know the city, you want to know the state, because that gives you an idea of the biome, the idea of the weather, the idea of the environment. And you want to say roadside, because that is saying, hey, it's near asphalt and cars and people, as opposed to forest, right? Or untouched parkland or grassland. Okay, so that's the level of specificity, not an exact pinpoint location. Now, you will find some papers put in coordinates for things. That can be super useful, but that isn't nearly as common in general entomological literature. That's more for people who are describing, say, a rare species or a new species, because that way you can get as specific as physically possible, and you sometimes need that. But in general, when you're mentioning places, you want to put the general area, the city, and the state, not the roadside names. And now I've mentioned that like 12 times. You might just see this in a paper in the future that you might have to fix. Keep that in mind. Okay, up next, when we're talking about materials and methods, you're going to be writing in past tense. So this already happened. So in a few weeks, you're going to start writing a paper from a protocol. And when you write up your own research, you're going to be writing from your own protocol. Protocols are usually in present or future tense because it hasn't been done yet or you're doing it right now. The experiment that you're writing up has already been done, so it's in past tense. So you want to say things like, we did this, this happened, this was done, that sort of thing. So you want to write in past tense in the materials and methods, not in present or future tense, because you're writing the results. You already did it. Write like you did. Another thing I notice in a lot of new scientific writers is when you are writing from a protocol. Remember all these different protocols that you've used in your various science classes. They usually give you ways of labeling things, right? And that's important in a protocol. And when I give you your mock protocol, you'll see how I labeled it. You want to know those labels in the protocol because you want to know what things mean. In the actual scientific paper, do not put labeling. We get it. You label things. Scientists understand that it's important to label things. I mean, we know. Each scientist, though, has his or her own method for labeling stuff. So they have their own methods. It's a personalized shorthand. And as you get into your own scientific careers, you'll find that you have your own shorthand. Some people like using numbers, some like letters, some like using colors and pictures and whatever else. Doesn't matter. You don't need that information to understand the results of the paper. So again, when you're writing out the materials and methods, always think about a scientist in a different country. What are they going to need in order to replicate your work? They don't need your labeling scheme at all. They have their own. It's just going to muddle up your paper. You're trying to be as clear as possible without being so bogged down in details that people hate you. So keep that in mind. We get it. You label things. You don't need to say, I labeled this Petri dish with an A. Okay, I'm going to label it with a 2. What are you going to do? It's not going to change the results. So anything that you put in materials and methods has to be something that might change the results. How you labeled something will not. So just use that rule of thumb. Think about, would this change the results if I put it in here? Or if I didn't and somebody tried to replicate it? If the answer is it's not going to matter one way or the other, don't put it in there. Got it? Okay. So you want to really just focus on the stuff that is important to recreate the experiment. What name you put on a plate or on a tube is not going to affect the outcome of that experiment. We assume that you label things or else you wouldn't have the right data. All right. Now, on to words. These are some of the words that I found that are commonly misused in entomological writing. And so I want you to know about them right off the top. First and foremost, When we talk about egg-bearing insects, insects that produce eggs, or even larviparous insects, a female fly, say, or a female specimen with fully developed eggs is called gravid, not pregnant. So pregnancy is reserved for mammalian specimens. So if you get into wildlife and fisheries, you might be able to say pregnant. In entomology, we say gravid. So gravid means an organism with fully formed eggs ready to oviposit, or an organism with fully formed larvae ready to larviposit, or fully formed pupae ready to their puparious organism. So gravid is the word you're looking for, not pregnant. Second, data. The word data is plural. Okay, so this is something that we're used to hearing, like the data is it's talking about it like it's singular. That's not correct. The word data is plural, so it should say data were analyzed. These data were looked at, or these data were considered, not the data was. So data is plural, not singular. Now, when you're dealing with the larval phase of insects, in holometabolous insects, say, the word larvae with the AE at the end is plural, and larva is singular. So if you have more than one specimen, more than one maggot, say, you have larvae. If you have a single maggot, it's a larva. Okay, so larvae is plural, larva is singular. Finally, you're going to see this term quite a bit. When you feed organisms as much as they can eat, say we're keeping a colony of flies or beetles or whatever else, we describe it by using the term ad libitum. This means at liberty in English. Okay, so ad libitum means at liberty. It's used when we just free feed an animal. You put a bunch of food, either, plants for caterpillars, or meat for maggots, or sugar for flies, or whatever else. Okay, so we say that we gave them sugar ad libitum, and you italicize it. So it's an italicized word, or phrase, ad libitum. Right? And it just basically means we let them feed themselves instead of restricting their food. So there are some experiments where we're only giving them a certain amount of food. In that case, you want to specify exactly how much. But if you just put a bunch of food in there and let them feed at will, it's ad libitum. Makes sense? And you always, always, always italicize that term. Okay. Now, here is something else for citations. Now, I talked about this when we went through what and when to cite. But again, it's something that needs to be harped on. Anything you look up, if you have to go look up a number, if you have to go look up a name, if anything you have to go look up because you didn't have it just in your head from, say, kindergarten, cite it. Seriously, just cite everything. Cite absolutely everything. When in doubt, cite it. If you have a question about should you cite it, yes, you need to cite it. If there's even a thought in your mind, do I need to cite this? Yes, cite it. Now, it is perfectly fine to go and just find sort of like the first reference you can with that information. Maybe you don't remember where you got that information. Maybe you listened to me talk one day and I said something like, Chrysomya rufacis is found in the southern U.S. You go, oh, okay, it's found in the southern U.S. Great. You write that in a paper, go and find another paper that has that info. This is something that we do all the time. We'll sit in talks, or we'll talk to people one-on-one, or we'll read in a textbook. Like, oh yeah, this is a thing. And then you remember it later on and you put it in a paper that you're writing. You can't assume that everybody has read the exact same thing that you have. You can't assume that they have the exact same thoughts or put the same connections together. You have to lead them down that path again. So cite everything. So what I usually do is when I have something like that in my brain, I try to find a primary resource. You want to cite primary resources more often than secondary, simply because primary resources are much more reliable. People can go and look at them. They can see that they're peer-reviewed. They can see that they pass some stringent checks of many, many people. Things like textbooks, websites, whatever, anybody can write. And so they're not a good defense at all. Imagine, again, I'm going to keep coming back to sitting on the stand because that's the sort of scariest place I can think of for having to defend yourself. So when I sit on the stand, even as an expert witness, I can sit up there and say, well, I read this in a textbook. think about the jury going, okay, but who wrote the textbook? Was it just some dude? Or just like some rando person who's like, I'm going to write a textbook and name it something. And with how often people can self-publish, oh, that's nothing. But if you say it was written in this journal article, and this is how it was referenced, and this is how it was, the quality control for this article, that is much better. So err on the side of caution always. Cite absolutely everything that needs to be looked up in any way, and try to go for a primary article. So I have many times gone through and gone like, oh yeah, I remember reading this in some textbook somewhere. Just go to Google Scholar, do a search for that subject, find a paper that says what you know is true, and cite it. Done. So you should have in a good paper at least a 2-page long reference section for all the things that you've cited. So that's just in general a rule of thumb that I try to go for. Just a normal couple of page paper, about 2 pages should be citations. All right. Now the last thing you need to look at is meeting the minimum word requirement. So I'm sure you have sat in classes before where professors have said things like you need to write at least 300 words or 500 words or a page or whatever else. One of the many reasons we ask you to do this, first and foremost, is because we want to make sure that you're actually putting in information and doing your work. You don't want to shortchange something. So we want you to go look stuff up and learn things. Hey, but other things is when you get into writing for science, you're going to see that there's a minimum word count for a lot of things. And we want just you to get used to actually meeting that minimum word count. So you want to make sure you meet those minimum word counts. If you need information or inspiration in order to pad out your paper, go and find some published papers that are talking about the same subject. See what they wrote about. Copy them and then cite. Okay, so in this case, we often see abstracts that have a minimum word count of 300 to 500 words. They also have a maximum word count so you don't overwhelm somebody. Okay, so what you want to do is make sure you are meeting that minimum word count. You'll find that editors have gotten really, really good at just glancing at an abstract and being like, that's not even close to the minimum word count. You get a general idea of how many words are in an abstract after you've read a bunch of them. So by the end of this semester, you will also be pretty good at just looking at a paper and being like, why is this only like 100 words? That's 2 sentences. What are you doing? It needs to be 500 words. What's wrong with you? Yeah. So make sure you meet that minimum word count. If you need to quickly count the words, all the word processing software now, usually in the bottom right of the document you're working on, will have a running word count. Or you can highlight the words and count the words through Word or through Google Docs or whatever it is you're using. So make sure you are reading that minimum word count, and if you run out of information to say, go back to your paper collection, find a paper that is talking about the same subjects. What did they talk about? Let's add that in, I guess. You know. Okay, so that's the very basics there. All right. So that's everything that I've written or I've noticed over the years, the most common differences between entomological scientific writing and other subjects. So now that you know it, this is what you're going to be writing about. Let me know if you have any questions.